But let's get started. So I was saying that this is going to be an informal overview of our institute effort, just to bring, maybe potential collaborators amongst you, new students, postdocs who may be thinking of joining the effort, make them familiar with what we envision here. And of course, going further, we will be having these talks every 2 weeks, and they will start becoming more technical. So the first few we have lined up are sort of to give you, this one is really an overview. The next one will go into more detail in the cognitive and social sciences effort. Then there's one on AI for public health and AI for disasters. And going forth, they will be on specific topics. But this one is just higher level. So yes, this is our effort, which is part of the 25 AI institutes that NSF has funded so far. The one we are leading is on AI Institute for Societal Decision Making. I'll explain what that means. Carnegie Mellon University is the lead on that. And we have a lot of great partner organizations that are also core in our effort, which includes Harvard, Howard, Texas A&M, Penn State, University of Washington, and Navajo Tech. These are all academic organizations. We also have MITRE. That's a federally, an agency that runs FFDRCs, which are federally funded research and development centers, including SEI. And we also have high schools as part of this. In particular, Winchester Thurston School is part of some of our high school initiatives that I'll briefly mention at the end. So with that, let me just talk about what AI-SDM is for. I know the name may not make it clear, so I just wanted to say here's a brief way to remember it. It's about improving decision-making using AI to benefit society. Okay, so it's really about that, coming up with AI tools that can help support decision-making where humans may have challenges, and we'll talk about the specific use cases we are looking on, and they will be in terms of the use cases we have chosen are around benefiting society, and the specific aspect we focus on is essentially human-centric decision-making, in particular AI support for making human-centric decisions. In public health is one of the application domains, and disaster management is another one we are looking at. Okay, the reason I call it human-centric is because these are societal contexts. So whatever AI recommendations, AI decisions, algorithms that we develop, they need to be accepted by the stakeholders that are involved. And so we really have to think about the human aspect in the loop, right? What kind of feedback you can get from human? How can you make sure that the algorithms you develop have trust and are actually like complementing the effort of the stakeholders there? So example projects that we are focusing on, I'll go in a little bit more detail in the as we go further, but some of them are around resource allocations. So in a disaster setting, you can think of allocation of drones, allocation of food, shelter, and other ambulances, first aid kits, even first responders, questions of that form, broadly speaking. In health, these are allocations of community health workers, also placement of clinics, optimizing those under multiple competing criteria. Okay, so these efforts are focused at more maybe the policy makers. We also have efforts that are focused on individuals. So we have, for example, in the public health space, we have personalized maternal health interventions. So here we are looking at how can we target interventions to retain the engagement of maternal patients with health services so that they don't drop out and lead to adversarial outcomes. And similarly, in the disaster space, we are looking at timely recommendations, so essentially effective risk communication so that you can make the people aware and that they respond to whatever guidelines are issued regarding evacuation, shelter, navigation, and so on. So why is it needed now? I guess couldn't be a more timely thing given what we have experienced and are continuing to experience in the last few years. Starting from the COVID-19 pandemic, where in particular, you can see that the US was hard hit by the number of excess potential years of life lost. And in particular, it has affected different minority groups in the hardest. So there clearly is a need. In fact, each one of us has probably influenced, or appreciated the impact of decision-making during this such a health scenario that came up. And disasters is another one, right? Even in the past month, we have witnessed Maui, Morocco, Libya, right? There are so many disaster situations that, and they're really increasing going forward. So I think this effort was really timely. I'm glad we chose these as the use cases. And in fact, there is one other thing that we are really trying to leverage. I think there's a real opportunity here at the confluence of AI, right? using AI, but in particular in conjunction with the social sciences. What I mean by that is social, behavioral, cognitive scientists who understand the human decision-making side of it. We need to advance not only AI for decision-making, but also AI to understand human decision-making and really bridge the two and bring them together. So I think it's that confluence that we are really trying to leverage via this institute. Okay, and that it's important because of the use of AI in societal context. There are not too many market forces driving these applications, right? What we really need to connect with the people here, and it's important to, I think, bring in the people who already understand human decision-making very well. So to give a vision of how we came up with the institute concept was essentially around bringing the AI researchers together with the social sciences researchers, and in these two particular use cases of public health and disaster management. So our research efforts are also towards integrating these disciplines together. And then these will be supported, the research we'll do at this intersection will be supported by education and outreach efforts that I'll briefly go over at the end as well. And this includes working with community colleges, working with high schools, but also upskilling emergency managers, public health officials, as well as engagement with raising awareness amongst the public about the impact of AI in society. So just to maybe keep an example application in mind here, right, or an example scenario of bringing AI and social sciences together for a use case, I would like to bring up the example of people on the team like Robin, who's from Texas A&M, and Howie here at CMU, who have been working on using AI for disasters. In particular, use of like drones during disaster scenarios. They have deployed with several, I think Robin has deployed with more than 20 plus disasters, as she says, not of her own making in these cases. And also, they have a disaster city down in Texas A&M that's also part of this, where they actually train all 28 FEMA urban search and rescue teams. So we have a very nice facility for actually being able to engage with these, the emergency managers, and see them operating in real life, and actually influence their decisions by working with them towards what's most useful in terms of decision support making, right? And of course, the reason you might want to use AI is that these decisions are very complex. Very often you're having to deal with multiple competing criteria, right? If you send a drone out to map out the area where it spots a victim, what should it do, right? So you have to make these type of choices. The data is typically incomplete, but multiple sources of data exist. So you have multiple streams coming in asynchronously at different times. And of course, you're working with very limited resources. So this clearly challenges the ability of the emergency managers to, optimize in this space, make the most efficient decisions, because they may be overwhelmed, tired, biased, right, and so on. But there are challenges for AI, right? Because one, we need to make sure that we take into account how the stakeholders view, right, the risk and the ethics of using AI technologies, as well as, and this is the reason we bring on people like Terry, who's a sociologist from Howard, and Koti here, who works, she's a cognitive scientist at CMU, who actually work with doing behavioral studies and surveys with the emergency responders. So now you're thinking of like bringing in people who have been working also with emergency managers, but from a different perspective. Instead of helping them with AI, they've been involved in understanding how people make decisions, how they do different trade-offs, what's important to them when making a decision or not. And so this effort is towards really bringing AI researchers together with social and cognitive scientists to really make a difference in these type of scenarios. So what kind of interface do I think will be able to achieve, or what kind of integration we are hoping for between these three sort of pillars of our institute? One, on the social sciences side, and I use social sciences broadly to mean social, cognitive, or behavioral science. We believe that these can be used to inform AI, for example, by providing what are human-centric metrics that AI should be optimizing. A lot of times AI algorithms are just designed, given a metric, a mathematical objective that may not have a good rationale, right? It's very hard to design reward for such complex scenarios like disasters. We can do it for toy problems about solving a maze or something like that, but it's very hard to come up with a numerical metric that AI algorithms can optimize. So social science research can help inform the design of such metrics. They can help inform the human AI complementarity. For example, Cody's work that I mentioned, decision sciences, she works on some certain games that people can play, and you can understand how they are making decisions while playing those games about, where they may be better, how they, when they're interacting with an AI bot, how they might behave. So you really have an opportunity to understand human AI complementarity and then bring that knowledge when designing the AI algorithms. Also, social scientists can provide models of human decisions that are not trained on data, right? But they are coming from the cognitive theories that they built. So these are zero data models. That's how at least I like to think of this. But they are built off of prior knowledge, all the studies that the scientists do, cognitive scientists and behavioral scientists do with humans. So models of that we can then use in an AI algorithm to try to optimize with. And then they provide actionable factors. What are the things that humans would actually act upon, right? That information also comes from social sciences. Of course, they can also inform the use cases by, again, the design of metrics, but also data collection requirements and guidelines around randomized control trials and some of the disaster drills that we'll talk about. Of course, AI can also inform both the social sciences and the use cases. Social sciences by providing data-driven models of human decision-making, and also providing algorithms for optimizing the models they already have. Of course, in the use cases, the research we'll do will come up with autonomous as well as hybrid decision-making algorithms that can then be deployed. And in fact, that's where our use cases will come in, because they will serve to both inform the AI and social sciences and also validate it. So on the informing side, the behavioral surveys, desktop virtual exercises we'll do with public health officials, the public, as well as emergency managers will come in. And in terms of validation, we are partnered with a lot of NGOs, as well as emergency management departments, health state agencies to do some pilot deployments in terms of resource allocations, as well as randomized control trials and disaster drills at the disaster city I was talking about at Texas A&M earlier. So a brief overview of the team before I get more into the research. I already mentioned that we have all these great partners that are core organizations, but I just want to highlight here that essentially, and this is by no means completely representative in the sense that, of course, we have people who are closer to the use cases like public health and disaster management from Harvard, CMU, and Texas A&M. As I mentioned, there are a lot of folks working on AI research, but many of them have overlaps. Right, some of you may be seeing Ronnie there, and he's the machine learning head, but he's under public health and so on, and clearly other people also here. So they really work at intersections. I'm just showing them as separate to say we do have, brought people together to cover all these areas, the social and cognitive and behavioral sciences, as well as a strong team working on education and outreach opportunities as well. And really coming from across all these organizations that will be working together. In addition to the core organizations, we have partnered with several government agencies. In particular, I'll mention later, there are 14 state health agencies that we have a partnership with, and we are obtaining data from. We are also working with emergency management departments down in Texas and also here in Pennsylvania, in addition to American Red Cross, which will show up somewhere in the NGOs. So a lot of NGOs and private companies, in particular, NGOs like Arman and Khushi Baby, who are in India, we have done some large-scale, or our partners have done some large-scale randomized controlled trials with them around maternal health. There's also, and these are Google India has been actually also quite engaging in establishing connections with them and conducting these large-scale trials, but also local NGOs like Naima Health is a company right based in Pittsburgh, out of University of Pittsburgh, that is doing something similar with maternal patients using an app-based platform that I'll talk about. But also other international partners like placement of clinics work we'll be doing will be with government of Madagascar, their Ministry of Health. And you can see various other like educational partners here where we'll be reaching out to more than 30 community colleges, as well as public schools. I think our target is around 40 public schools that we'll try to engage with. Okay, and you'll see more of these show up as we talk about the research. So with that, I'll get into a little bit more specifics on the research plan. So broadly speaking, I mean, it sounds a lot of applied, and because yes, we are inspired by these use cases that we have chosen, but it is an NSF-funded institute, means there's a lot of foundational AI research that will go on in this effort. So we are looking at broadly two sets of challenges. They are the AI capability challenges where we are thinking about adaptivity to dynamics, right? So the agents, the data, all of these things in this model, in these settings, come up asynchronously, right? They might show up at any time. Situations are continuously evolving. The resource constraints are also evolving. So how can we take into account these dynamics of resources, constraints, data, decision makers when they come in, as well as changing beliefs and risk perceptions? The second focus is on robustness to uncertainty. So clearly you have to work with a lot of uncertain aspects, right? You may not know fully about, you only have partial information about many things, even the resources that may be available to you, and so on. You have multiple sources typically, but each one is highly incomplete, as well as efficiency under resource constraints. So as I said, you're optimizing multiple competing criteria, and so you have to be able to do this efficiently. And some of these things, challenges, even though they have been addressed under what we call the easy applications of decision-making using AI so far, but I think those are monolithic, simple applications where it's still possible to come up with reward metrics and do this. The kind of things we are talking about, it's much harder to think about what should be the right reward, right? What should be the competing criteria we are talking about, and inferring them is also part of it. Another major aspect is the social acceptability challenges, right? So here, our focus is on developing algorithms and recommendations that are safe and ethical, and that will really be accepted by the people, because, you know, making sure that they are explainable, that they appeal to the perceptions and the biases that people have. So broadly speaking, we break up our research plan into some foundational research efforts that I'd like to break up by essentially thinking of the human piece, the autonomous piece, and then the collective piece. And there's a cross-cutting causal and counterfactual reasoning that comes up in all of this. And in terms of use cases, it's on resource allocations and interventions, as I talked about. And the cross-cutting theme is the adoption of AI decision support. Okay. So if you have any quick questions, I can answer now, but also happy to discuss more later. So let me go a little bit into each one. I'll actually start with the use cases because I think they serve as inspiration for the foundational questions we try to answer. So let me start with the first one, which is focused on resource allocation. So here we are looking at doing decision support for dynamic and equitable resource allocation, right? So doing this such that we make sure that there's equity across all the stakeholders, while working with dynamic environments where the resources might be, the constraints might be coming and going, the demands might be going up and down. And in particular, here, some of the projects we are looking at, in particular, there's the one with the 14 state health agencies. They are interested in doing studies around incentives to get the healthcare labor market back up, right? Right now, there's a big gap in the demand and the supply for healthcare workers. And so can we come up with the right incentives? So this would be whether allocating resources of different types, whether there are allocations around training, whether there are allocations around, monetary compensation, flexibility of work schedules, and so on, so that we can meet the demands. So this involves first, of course, qualitative and quantitative studies to understand, right, how do the decision makers weigh the equity concerns, the risks, and so on, what features are most informative to the decisions. Then using the data that we have from these agencies to do demand forecasting. How much is the requirement of each profession, for example, in a healthcare, healthcare labor setting? And then coming up with algorithms, such as coupled bandits and oral algorithms that are trying to allocate resources to a heterogeneous group of people, while incorporating whatever feedback we get from the decision makers. Okay. And this that's one of the applications. The other one is with Madagascar Government Ministry of Health, who are interested in setting up clinics, I think around 50 of them over the next few years. And they're also, it's about working with the different districts that they have and geographic locations to understand their needs, doing forecasting of their requirements, but then also taking the social cultural factors into account while prescribing where the optimal allocations or placement of these clinics should be. In parallel, during disasters, we are looking at polycentric allocation. What I mean by that is, in contrast to in health space, a lot of the decisions are still central, right? Or there's a central, a coordination that goes on in making these decisions. In a disaster setting, that's not the case. They're only loosely coordinated they're really polycentric because American Red Cross comes in with their own set of things that they can help with. Then there are the emergency managers, then there are schools that may be providing shelters. All these agencies come in with their own purpose, and they're only loosely coordinating with each other. So it's again about doing resource allocations, but using multiple agents that may have slightly different objectives, different time scales, and different times at which they come in, with asynchronous information, high uncertainty. And around here, we are developing some disaster games and virtual desktop exercises to first understand the cognitive limitations and guide design of metrics to be used by AI. And we'll finally be demonstrating many of our methods, as I mentioned, in live disaster drills down at Disaster City at Texas A&M. Okay, on the intervention space, our focus is, one of them is this maternal health intervention I talked about. So this is in partnership with some large NGOs in India, but also this local organization that we have partnered with called My Healthy Pregnancy app. That's an app-based platform. But here our goal is to identify patients who are at most risk of adverse outcomes and of disengaging with the health services, and then doing targeted interventions at them. So around there, design of randomized controlled trials that appeals to the heterogeneity of the population, coming up with cognitive models that may describe the maternal patients, and identifying factors that drive engagement and then intervening on them to demonstrate that you can actually improve health outcomes. This has already been done to a small extent in one of our partnerships, where I said we've already been able to show that there's a 30% increase in engagement with health services by doing AI-based allocations or recommend interventions as compared to what they were currently doing. So in one case, it involves assigning community health workers to place calls. The other case, it would be app-based, providing app-based personalized content to keep the patients engaged. A parallel in the disaster setting is messaging during disasters, so evacuation, shelter recommendations, navigation recommendations, again, targeting the heterogeneity of human behavior. Here, you particularly have to understand human behavior under extreme conditions. So it's slightly different from maternal health, but still requires similar aspects, and developing an online decision-making exercise, and then doing, again, targeted risk communication interventions. The final use case is around adoption of AI decision support. So here we are looking at actually developing, this is the work that actually MITRE is in particular gonna lead, which is around developing a framework to predict whether an AI technology will be adopted or not, what ways of the AI and the decision-making maker interacting with each other lead to technology acceptance or not, and what societal factors may influence that use pattern, how the AI and human interacting will lead to adoption or not. So it's about first building a database of AI adoption cases. Initially, when I heard the idea, I was like, that's very hard to do. But somehow turns out MITRE, because they work across so many organizations, has this ability. They have several access to case studies. And in fact, we are looking for more. If in your research or otherwise you have encountered use cases where you tried an AI technology, it was adopted or not, whether it succeeded or failed, we want to know about it and build a database around AI adoption cases. And then using that to build a forecasting framework where you can take the social factors, the use patterns into account. Which way did the decision maker make a decision based on looking at the AI output? Did they make an independent decision, and how were they combined to come up at the final decision? So that was an overview of the use cases. Now I'll briefly talk about the foundational research. So the first one, which is focused on understanding human decision processes and modeling them better. So here, why do we need advances first? The goals are that if we just look at the current science of human decision-making, it's limited to simpler settings, like an online buying scenario, right? Where people are making simpler decisions about whether to buy a product or not buy a product. They're not as complex and dynamic as what you might encounter in a disaster setting, for example, right? So we are looking to advance the science of how humans make decisions when things are dynamically changing, how their own biases might change, and modeling all of that. At the same time, if you look at computational models, then they typically try to optimize a metric as opposed to being complementary to what the humans can do. So here our focus is on, making sure that they complement the human cognitive processes and don't try to compete or do better than the humans. And specific projects, example projects under this include one, as I was talking about, this interactive platforms or games that can efficiently elicit human preferences in complex environments. For example, one of them is using micro worlds to understand how people make decisions and trade off different criteria. We are also planning to build another one around resource allocation in disasters, where there are multiple agencies trying to loosely coordinate and do resource allocations in a dynamic and timely scenario. Another is just building these social cognitive models that are talking about essentially dynamics situations again, and thinking about how people, as the circumstances might change, how their own preferences might evolve, right? Understanding that and capturing that in addition to their own biases and limitations. And the third piece of this, and a very important piece, is the complementarity, studying that between humans and AI decision models. So this is where thinking about under what circumstances do they complement each other, what are the factors governing whether the human-AI complementarity will work or not, and then designing hybrid decision-making systems that integrate the strengths of both. On the autonomous side, we are working towards addressing autonomous decision-making under multiple competing criteria, and when you have heterogeneous agents, building trust, right, with uncertainty quantification, because you want to make sure that these systems are used and you can give guarantees about how they will behave in complex scenarios. So one of the projects is around achieving efficiency under multiple competing criteria. So this is looking at multi-objective like Pareto optimality, using in bandits, reinforcement learning kind of settings, but also looking at combining online and offline data to make it more efficient, counterfactual data augmentation in this setting as well. Another one is around uncertainty quantification, as I mentioned. So doing robust and well-calibrated uncertainty quantification in out-of-domain, out-of-distribution settings. Also leveraging multimodal and multi-view learning and even multitask. When you are solving multiple tasks together, how can you reduce the uncertainty by leveraging the fact that you may have data on different tasks, providing different information. Finally, the multi-agent part of it. So how can we get multiple agents cooperating, whether that cooperation is in like a computation limited scenario or in a communication limited scenario. So this will help model our polycentric decisions in disasters, where you may be communication limited, only coordinating once in a while, but of course, computation limited is equally relevant as well. Moving on to the collective decision-making, this is where we now bring the human and the autonomous pieces together. So here our goals are to understand some collective social values that emerge and group behavior to inform human-AI teaming, the design of society-centric metrics, not individual-centric metrics now, but society-centric or group metrics for AI, and then effective social interventions. Again, not targeted at individuals necessarily, but at achieving a good that's for an entire group or a society. So project here include robust aggregation of heterogeneous forecasts and decisions. So here work like distribution-free confidence sequences that can influence the aggregation without making strong modeling assumptions. Also algorithms that are robust to things like model misspecification, distribution shifts are what we'll be investigating. Another one is around computational social choice and coming up with models for that. In particular, of course, there's a long literature of social choice theory that exists, which talks about how under different axiomatic conditions, you can have different types of social welfare emerge. But typically, those social welfare functions are fixed and hard-coded. What we are thinking about is, can we actually use data, because we have access to it, to learn the social welfare functions, which would mean training machine learning algorithms, but that satisfy the axioms that come from social choice theory, right? For example, social choice theory may tell you that things are homogeneous. If you scale the utility of one agent, it scales the overall, or if you scale it for every agent, you scale the overall utility by the same amount, or agents are interchangeable. And there are many other such constraints that come from social choice theory that we'd like to bring in as constraints on machine learning functions. and learn them. And a subsequent step is deliberation models. Instead of just having models that tell you how to aggregate, can we actually learn models for deliberation? How people may start out with opposing views and then with arguments arrive at a consensus. So there are no good models for doing that. There are aggregation models, but not deliberation models, and we'd like to develop those. And of course, all this goes into ultimately algorithms that can enable resource allocations and interventions, taking into account the social characteristics, the social welfare, and doing dynamic allocation under changing constraints, and personalized interventions also that take into account the socio-cognitive factors. The last but not the least part is the causal and counterfactual reasoning that's really needed throughout. It's a cross-cutting thrust. So here, I think some of the innovations we are looking for are around using counterfactual reasoning, but to enable decision-making, right? So our focus is still decision-making. How can we guide interventions using counterfactual reasoning? And of course, enabling explainability as well. So some of the newer directions are looking at latent causal variables, when you may have certain variables that are hidden, you don't observe them directly, but that can have an influence on the things that you observe. In what cases can you identify such causal variables? Can you do that in high dimensional settings? What about leveraging human feedback when learning the causal models? So can you combine the power of data and humans when doing that? And another idea is counterfactual interventions. Instead of just using counterfactual explanations that tell you, right, what may be the outcome if you change an input, you want to be able to suggest inputs that you would like to change that are actually actionable, that can lead to a different outcome. Okay, so this is also known as the idea of algorithmic recourse, if you've heard of that, but it's about using counterfactuals to generate recommendations, actionable advice, as opposed to just an explanation. All right. Now, briefly, I think that was the research plan. I'll just very briefly mention some of our education and outreach efforts in case you have parallel efforts that we can coordinate with, or you would like to be engaged with any of those. So what we're thinking of here is really contributing towards developing a diverse AI workforce that's centered on developing, deploying, or just leveraging AI, but really generally using AI, and in particular human-centered AI, grassroots up. So at the high school level, we are going to be running some research at AI-SDM workshops. These are for high school educators. In fact, this is where Winchester Thurston, who's a local school that has partnered with us, they already have a curriculum developed, and they have been teaching this course on AI and society for the last, I think now 4 or 5 years. And we want to be able to take that, convert it into a modular form, and actually with participatory design from other high schools across the country, really. So all of the participating organizations like University of Washington is there, Texas A&M, Penn State, right, Harvard, everybody will connect with their local high schools. And we are hoping to build on the content developed at Winchester Thurston and be able to disseminate that to the high school educators so that they can incorporate it in their regular curriculum. At the community college and undergraduate level, one of the key focus, and I'm only mentioning the key pieces here, is development of a project-based, hands-on, experience design for community colleges. And here, some of our team members already have partnerships with a lot of community colleges. We are aiming for 30 plus community colleges that we'll be, hoping to implement this curriculum with. The curriculum will be around, again, use of AI in public health and disaster management scenarios. At the graduate level, one thing that we are hoping to achieve is propose a joint degree that really cuts across AI and social sciences. So hopefully it will bring our 2 colleges, the School of Computer Science and the Dietrich College, even closer together. I know we already have some joint degrees with STAT, but we are hoping to extend that to SCS here, Social and Decision Sciences. And of course, part of that will be some new courses that will be offered at this intersection of human and AI decision making. Finally, quickly on the outreach and knowledge transfer.
One thing that I'm really proud of is that our team has majority leadership, including co-PIs, management team, and thrust leads that are women and BIPOC, and we hope to capitalize on it.
Many of our partners are already engaged with several outreach efforts, but we really want to build on that and provide AI pathways to underserved communities, including building leadership training. Because I feel like our team already has that. We have a lot of leadership around that, and we want to be able to, synchronize amongst us, develop best practices, and deliver those to the new generation. Part of this would also be we'll be running some student-run podcasts. So if you're interested in doing those, leading those, please connect with me. We'll also be doing some public-facing seminars in partnership with local public libraries that you'll be hearing about as they're set up. Okay. Finally, I briefly mentioned knowledge transfer. So of course, we are partnering with all these NGOs and different health and agencies and emergency agencies for research purposes. But also we are working with them to develop some content that we can be used for upskilling or continual learning. So in particular, module certificate courses on AI and decision making, that's one thing that's on our radar that we'll try to come up with. Another thing is building training modules on AI for emergency managers. So again, this is where I think the disaster city connection would be very helpful. And of course, other engagement would look like internships for our students at any of the agencies that partner with us. All right, so that's really all. I just want to summarize that we are really hoping to transform decision making in these societal domains, particularly public health and disaster management, by advancing, but also really bringing together AI and social sciences. That's really our hope. We'll do this by advancing foundational research on both human, autonomous, and the hybrid spectrum, applying it to the use cases in public health and disaster management, and then also the outreach and education efforts as well. So we're all ears. If you want to partner with us on anything, I'm happy to make connections, facilitate connections. I know NSF wants to use these platforms to not really be standalone institutes, but really to grow as nexus points. So to the extent that you want to write proposals leveraging us, we are also willing to work on that, identify the right people within the team who may be good partners, or if you're doing parallel research, you just want to know that. Thank you. If there are any questions, comments, generally feel free to speak up. If you want to come up, I'll stick around for some time to answer any queries. Yes.
Internationally, are you still looking at different geographic areas to focus on, or is it mostly topical, what you're thinking of in terms of expansion?
So
could you repeat the question?
Sure. So the question was, internationally, are we looking focusing on specific areas, or are we looking to broaden?
Right.
To
it
other,
seems like you're mostly focused on the research topics, and then be what it is, the use case, the actual implementation can be anywhere.
So yes, actually that is true. We are focusing on developing the foundational algorithms, right? The foundational advances in both human decision science and AI-based decision science. But really application areas are very open. In fact, even public health and disaster management are just two application areas we focus on. As long as it's any other domain that's of interest, any other international partner or local partner that's of interest. I just mentioned the ones that we had a partnership with or a conversation going already. But we will be building these further as we go. So we are totally open to other collaborations, international or local. That's okay. Well, again, I'll hang out if anybody has wants to discuss anything specifically. But thank you.